Welcome to qnawire.
Let's determine which experiments are binomial distributions. In order to be a binomial experiment, you must agree with these four statements. Each observation falls into one of just two categories, which we call success or failure. There is a fixed number of observations that we call n. The observations are independent, meaning knowing the result of one does not affect the next, and the probability of success p is the same for each observation. In our first example, we are surveying 100 people to determine if they like Sudsy Soap. So first, each observation does fall into two categories, success or failure. They either like the soap or they don't. Two, there's a fixed number of observations. We are surveying 100 people, so n equals 100. Each observation is independent because the first person does not affect the second person's opinion. And lastly, the probability of success is the same for all observations because you either like the soap or you don't. The next example says tossing a coin 100 times. Each observation falls into just two categories. You either get heads or tails. There is a fixed number of observations, or tossing the coin 100 times. Each observation is independent because it doesn't matter if you get tails the first time, you can still get tails the second time. Knowing the result of one does not affect the result of the next. And the probability of success is the same each time, which is 0.50. You're either going to get heads or tails. How about for drawing a card with replacement and getting a heart? For this one, you fall into two categories. You either select the heart or you don't. We don't know the fixed number of observations for this one. So in order to be a binomial experiment, we would want to know how many times we are selecting a card. The other observations, it is independent because the first heart does not depend on the second heart because it says the words with replacement, which assumes independence. And the probability of this success is the same each time because you are putting the card back into the deck, so it doesn't affect the probability. The probability does not change each time. So in order for this to be a binomial distribution, we would need to know the number of observations. The next example says asking 1,000 people which brand of cigarettes they prefer to smoke. For this one, it is not a binomial distribution because each observation does not fall into just one or two categories. There can be an unlimited amount of cigarette brands, so this is not a binomial distribution. The last one says that you're testing 4 aspirin brands to determine if they are successful. So when we're testing the brands, we can say if they're successful or not, but there's 4 different types of aspirin, so there's too many categories for each one, so this is not a binomial distribution. We also don't know the number of observations. They are independent, but the probability of success can change each time because they're testing 4 different types of aspirins, not just one.